Welcome to the session. Now we are going to see about universal Turing machine. So far we have seen few problems on Turing machine. When we see this Turing machine, each Turing machine appears to be specialized in solving a particular problem. Computers solve many different problems and they are known as general purpose programmable machine. So when we compare this computer with the Turing machine, we'll have the question raised, can we also program a Turing machine? Yes. So when we answer this question, the stored program concept came into picture, which executes a program or instruction using the input stored in the memory. So we can program a Turing machine like this computer. Universal Turing machine can be programmed to solve any problem that can be solved by any Turing machine. So the concept here is you have to encode the machine M, Turing machine M, and also the input string W, which belongs to sigma closure, is also to be encoded, and automatically your output should also be an encoded one. So for this we'll have this this is my tuple of Turing machine. So set of states, input, and we'll have this tape symbols. Transition function will have this start state, and we'll have this blank symbol, and it has a final state. So the generic move can be defined as, when we'll have the tape symbol 0, 1, B, it should be replaced by x1, x2, x3 respectively, and we'll have this L and R, it should be replaced by D1 and D2 respectively, and we'll have this generic move, which is this is known as instantaneous description. For example, the del of qi comma xj equal to qk xl and dm. For example, if you are in state qi and on input xj, you have to move the state qk and replacing the xj by xl and move the direction at dm. So after this we'll have this binary encoding of the Turing machine will be look like this, and the first and last will be a 111. In between we'll have this generic move encoding code, and between separated by 211, and so this is the binary code of Turing machine. So the code is denoted by, you will have this machine followed by your input symbol, input string W, right? So for this we'll have this example. So obtain the code for the machine M0011, where we'll have this 3 states and 01, 01B, and we'll have this mouse. Okay, so for the how the Turing machine will be look like. So it's like a concept, it's a theoretical one, and we'll have this we have to make the encoding part of this particular Turing machine. For example, the solution will be look like this. Tape symbol 01B will be represented by x1, x2, x3 respectively, and we'll have this direction like L and R, right, replaced by D1, D2 respectively, and we'll have this generic move qi xj equal to qk xl and dm. So for this, the first move is here. So q1 comma 0 equal to q2 0r. So this is our first move. So we have to rewritten as q1 comma 0. So 0 will be mentioned replaced by x1, right? So x1. So x1 equal to q2 x1, and it's r will be replaced by d2. Okay. So then we have to write this encoding like this. 0 power 1 will have separator, and 0 power 1 equal and will have separator, and 0 power 2 separator, 0 power 1 separator, and 0 power 2. So this is your first move. For the second move, q2 comma 0 equal to q2 comma 0 comma r. So here it is rewritten as actually this is our binary code, right? Binary code. So it's rewritten as q2 comma 0 will be replaced by x1 equal to q2 x1, r is replaced by d2, right? Okay, now 0 power 1 1. So this is 0 power 2, which is q2, right? 0 power 2 1 0 power 1 1 0 power 2 0 power 1 0 power 2. So see here, 0 power 2 0 power 1 is it's separated, and we'll have 0 power 2 and 0 power 1 0 power 2. So this is known as binary code for this one. Okay, we'll have this third move, q2 comma 1 equal to q2 comma 1 comma r. So rewritten as q2 comma 1 is replaced by, see here, 1 is replaced by x2, b is replaced by x3. So x2 equal to x2 and r is d2, right? So here we have to write like this: 0 power 2 0 power 2 and 0 power 2 0 power 2 and 0 power 2. These are all binary code for this move, right? Next, the fourth one is q2 comma b equal to q3 comma b comma l. So rewritten as so here b is represented by x3. So x3 equal to, we'll have this q3, right? B is also x3 and left will be d1. So it is 0 power 2 0 power 3 0 power 3 0 power 3 and 0 power 1. So this is my binary code. Okay, this is the way we have to be written. So now the binary code of Turing machines will have 111, code 1, 11, code 2, 11, code 3, 11, code 4, and we'll have this. So see here, so we'll have this 4 moves, right? For this we'll have this 4 codes. So 111 and final one will be our Turing machines basic machine encoding. Okay, so for that 111 MW is represented as 111. We'll have this code 1. What is this code 1? So this is my code 1. So expand it and write. So 0 power 1 0 1 0 1 0 0 1 0 1 0 0, and we'll have this is my binary code 2, right? You have to write 0 square, right? You have to write 0 0 1 0 1 0 0 1 0 1 0 0, and we'll have separate by 2 1. So we'll have this binary code 3. This is known as, so 0 0 1 0 0 1 0 0 1 0 0 1 0 0, followed by this separator, and finally you have this thing strings 0 0 1 0 0 1 0 0 1 0 0 1 0, and we'll have this final one. So this is known as machine code, and we'll have this input. So input will be represented as 0 0 1 1. So this is the way the binary encoding is done. See here, So when we use this universal Turing machine, the concept here is we have to encode the machine and also we have to encode the input stream, and obviously our result will be in binary code and encoding of all the encoding of machine input and output all are encoded in encoded format. Okay, so when we used to do the construction of a Turing machine, right? So they are suggesting we have to use multiple tapes. For example, the tape 1 keeps the transition of M encoded in binary, and tape 2 keeps a binary string W, and tape 3 holds the state of machine M with the state Qi. So we'll have to keep 3 tapes. So this is the easiest way to describe the universal Turing machine as a multi-tape Turing machine. So for this they are using 3 different types of tapes, and tape 1, tape 2, tape 3. Using this 3 tapes, we can easily calculate this kind of generic moves, and we have to achieve the encoding of Turing machine, universal Turing machine, to solve different problems like our computers. Thank you.